Hey guys, welcome to this page of the notes. What we're going to do is we're going to now talk about that ambiguous case, the one where you were given the side angle information about a triangle. We're going to talk about why it's the ambiguous case, sort of refresh your memory, because we did talk about this before back when we were doing the triangle congruence theorems. We talked about side angle and why that is not enough information to prove that triangles are congruent. And now again, why this side angle information is still going to be that ambiguous case where it's possible to have more than one triangle. Okay, so here's the reason why. Let me quickly run through this and explain to you what this means, this figure means, and how we're going to use it to solve problems. Here's what's going to happen. All right, when you are given side angle information, it is possible, depending on the height of the triangle. So, when doing these problems, this is a really important note I'll write right here. The first thing you must do is find h. Find the height of the triangle. First, find h. All right, I cannot overemphasize how important that is. Every single time we do one of these problems, in fact, every single time you get side angle information, find h. Find the value of h. Once you know h, then we can use the figure to figure out which case we have. Take a look at this. Once I know the value of h, if h is greater than the value of a is just the length of a side, right? And remember, I've given you side angle. So you're going to know the length of side A. You'll know it. Well, once you find the value of h, if h is greater than a, look, the triangle's not even possible. Side A is not long enough to close the triangle. You don't even have a triangle and you just stop there, right? You'd simply write does not exist or is not possible or something like that, and you're done. That's it. That's as long as you know that h is greater than a, and you'd have to find h. Okay, the other possibility is h and a are equal to each other, in which case there's only one possible triangle, and it's going to be a right triangle. Fantastic. No big deal. We can certainly solve this triangle using the law of sines or just the sine, cosine, and tangent function, because it will be a right triangle, and actually goes back to the previous chapter where we did right triangle trigonometry. But again, as long as you know the value of h and side, you will know the length of side A. If they're equal to each other, you got yourself an easy problem to do. This one's no problem. Actually, this would be just like problems we did in the previous chapter. Fantastic. Here's where it gets a little tricky. Remember, the first thing you do is find the value of h. Now I go ahead and compare h to the two sides that I was given, right? Side angle. You've been given the length of the sides, and here's what happens. H is less than a, and a is less than b. Here's the ambiguous case. Here's the ambiguous case. What happens is there are two possible triangles, and you can see that from the diagram. Either A can swing in, right, so that I've got this obtuse triangle right here where this angle is obtuse, or A can swing out, where I've got this larger triangle out here where all the angles of the sides are acute. But in this case, right, there's two possibilities. We're going to have to solve both of those possibilities, which is why we call it the ambiguous case. So if this happens, again, you're going to find the value of h. Once you know h, you compare it to the other two sides, and if h is less than a and a is less than b, you'll know you've got this case where there's two possible triangles, and we'll take a look at in a second at an example problem where we will go ahead and solve those problems. The last possibility is simply this. Again, the first thing you do is find the value of h, right? And what happens is actually the value of h didn't even really matter. You found it, that's awesome, but you go ahead and compare your numbers, and it turns out that side A is greater than side B. In which case, You didn't even need H. There's only one triangle that's possible. It is not a right triangle. You will need to use the law of sines to solve this triangle, but there's only one possible triangle anyway. We'll use the law of sines to solve it, and it's actually just like the problems we did on the previous page of the notes, where the law of sines will help you solve for any unknown angle measures. Right? So that's the way that these problems are going to work. First thing you're going to do is solve for H. Once you know H, compare it to the other two sides that you were given, and then match it to one of these possibilities. All right? Head on over to the next page of the notes. We'll take a look at our first example problem, and I'll meet you there.